Okay, in this video, we're supposed to find h of g of x. Now, the way I recommend doing the composition is I recommend starting with the outside function and go through that outside function and put parentheses wherever you see an x. So my outermost function is h of x, which is x squared minus 9. So what I'm going to start by writing is just an empty set of parentheses squared minus 9. Since the equation is x squared minus 9, I'm going to put parentheses squared minus 9. So instead of x, we have a blank set of parentheses. Now that I have that part done, I'm going to go back and fill in the parentheses with g of x. Well, g of x is 5 minus 4x. You'll notice that there's still an x inside the g of x parentheses, so x is not going to be replaced with anything. So g of x is 5 minus 4x. So there is the actual setup, and to go from here, it just depends on what it looks like. So sometimes you might just do a simple distribution and combine like terms. Other times it might be a little bit more complicated. This one, we have this binomial squared, so we're going to go ahead and simplify it. I'm just going to write it out twice and distribute it quickly here. And there's also a shortcut formula, but I know it can be sometimes hard to remember a bunch of different formulas. So this is always a tried and true way of going about doing it if you have trouble remembering formulas. So just distributing it through. There we go, and we got plus 16x squared. Since there's no other multiplication, I can just drop the parentheses after distributing, but I do have that minus 9, which I need to make sure to bring down here. Afterwards, combine like terms. It's not necessary to put it in standard form, but it is helpful for whoever is looking at it afterwards, and even you. So 16x squared is the highest power, so I'm going to put that first. Got negative 20x and negative 20x, which is negative 40x. And then 25 minus 9, which is 16. And there we have it. This one doesn't have any restrictions because we have no radicals or no fractions. It's just polynomials. So